Okay, so today we'll solve get 2022 question, 2020 question. This is the question number 10. This is a question from real analysis. So what it is saying that xn be a iterative sequence is given with the initial point x0 which is positive. Then the four options are given. You have to check which one is correct. So means it is saying that basically when the sequence will converge for which initial values. Okay. So this is the NPTEL reference. This you can check. Okay, let's start. So what is the sequence given? Xn equals to xn minus 1 by 2 plus 3 by xn minus 1 for n bigger than equals to 1, and the initial condition x0 is positive. Okay, so in order to check that this sequence converge, so basically we will check that this sequence. So let's check that is this sequence. So as x0 is positive, so which implies all the terms of the sequence is always positive, right? Because if you put it in the sequence, then so this is a positive sequence. Now we'll show that this is more, check that this is more to increasing or decreasing. So for that, let's check xn minus 1. So xn is by definition, this is xn minus 1 by 2 plus 3 by xn minus 1 minus xn minus 1. Then if you check, so this is 3 by xn minus 1. If you simplify, it will become xn minus 1 by 2. So if you again simplify, you will get 6 minus xn minus 1 square by 2xn minus 1. Right. So now we have to check that this is positive or negative. So for that, let's first estimate this. Now xn minus root 6, what is this? Let's first check this one. So xn is by definition xn minus 1 by 2 plus 3 by xn minus 1 minus square root 6. So if you simplify this one, then you will get 2 into xn minus 1. In the numerator it is xn minus 1 is square plus 6 minus 2 square root 6 xn minus 1. Right. So this you can write xn minus 1 minus root 6 whole square by 2 into xn minus 1. As all the terms of the sequence is positive, so in the denominator is positive and the numerator is always positive. So this becomes bigger than equals to 0. So it says that xn is bigger than root 6, right, for all n bigger than equals to 1. So which is same as xn minus 1 is bigger than root 6 for all n bigger than equals to 2. So basically this is saying that the sequence xn is bounded below, right? So the sequence xn is bounded below. Now from here you have get this, right? So from, if you put it here in this here, so as root 6 is less than xn minus 1 for all n bigger than 2, So 6 minus xn minus 1 square is always less than equals to 0 for n bigger than equals to 2. So therefore, so xn minus 1, that you have got 6 minus xn minus square by 2 into xn minus 1. So this is less than equals to 0 because the numerator is less than equals to 0, denominator is positive. So this is less than equals to 0. So which implies xn is less than xn minus 1. So which is same as that xn is monotonically decreasing. So xn is monotonically decreasing, and we have shown that this is also bounded below. So xn will converge. So xn will converge. Let limit n tends to infinity, xn will converge to some limit L. So let's say which value it will converge. So as xn equals to xn minus 1 by 2 plus, basically this we do not need to find. We don't need to find this you can find. So xn will converge, so we have for any x naught positive, because x naught is positive and we have got that this is monotonically decreasing and bounded below, so it will converge for any x naught positive. So let's check which option is correct. So it converges only if x naught bigger than 1, so this is not true because it converges for any x naught positive, so first one is false. Convergence only if x naught less than 3, this is also not true because this is converge for any x naught positive. This is converges for any x naught, and initially it is given that x naught is positive, so that's why it is converges for any x naught. So option C is correct and does not converge. This is also false. So option C is the correct option. Okay.